Meantime, though, let me introduce you to another economics professor who's going to give us her take on a very important issue, and that is critical raw materials. Already questions have been bubbling up about this, and I'm delighted, therefore, that we're joined now by Professor Aude Pommeret from the University of Savoie-Montblanc, and she's going to talk to us about the consequences for the energy transition if public policy ignores critical raw materials. Come along.
Thank you very much, Misha.
So good to have you with us, Aude.
Yeah, very happy to be there as well. So I'm going to take the macro perspective a lot more and start with this diagram, which gives you an idea on how critical raw materials, I will use CRM for the rest of the talk, are really important for the energy transition. So to give a precise example, if you use a wind plant in order to provide energy instead of a gas-fired plant, what you need is 13 times more mineral resources. Okay, and this is true in general for all you need to do the transition. And if you look at the left-hand side, you have the level of supply risk, and you see that the red is the highest one, and it goes to renewables, it goes to e-mobility. Okay, so that's really an issue, and already the International Energy Agency in 2021 was pointing that out. So it was already saying that if we want to have an evolving energy system, we need to have a broader approach, not only focusing on a narrow way to see the energy transition, but it should include critical raw materials in the map. And also, at some point in the report, you can find that there is a recommendation to scale up recycling. And more precisely, it is said by 2040, recycled quantity of copper, lithium, nickel, and cobalt from spent batteries, they could reduce combined primary supply requirement by 10%, okay, which is something. So if you start thinking accounting for this issue, what it changed a lot is your energy transition view, because there is very few in the big models, although in the policy plans for the energy transition, up to very recently, there were very few space for this issue. If you look at 2023, basically all the institutions now speak about it. So the IEA was the first one, but now you have the IMF, the World Bank, the UN, the OECD. You can find 2023 reports now on this issue. What you can think about it, so from an economic point of view, that was interesting. If you look at the history, you can have the impression that we just pushed a boundary. In 1970, we started with the problem of scarcity of fossil fuel, okay? Then we had a GES emission issue. As if you think about it like a carbon budget, that's the same. We had a new scarcity that led us to the problem that we cannot emit that much. And now we say, okay, let's do renewables, but with the renewables, it is as if now we have a new scarcity problem, which is linked to critical raw materials. But in the very last report, in particular, Irene was pointing out that there is a huge difference between characteristics of fossil fuels and critical raw materials. I mean, there are many, but one is important is that you can actually recycle critical raw material, which makes a difference, okay? And a huge one I'm going to go on with from now on. So I have a paper that you can find where we study in a macroeconomic dynamic framework how the timing and the main feature of the energy transition change if you take into account critical raw material. So we look, for instance, at what is the most important constraint. Is it climate change? Is it the constraint on the material? Okay, we also put inside the model a climate policy, and we put some recycling. So just to give you an idea on how it looks, then we can model the fossil resource transition, okay, going to zero. So depending on what type of policy you do, these are the two lines. You can have a look at how the minerals are used, and we can also see how we build the green capital. So what I mean by green capital is basically wind plants, okay, and all the solar panels. Then we had recycling. And what is interesting with recycling, what does it change? First, is that at the end, I mean, at the steady state, when you have completed the energy transition, you end up by having more green capital if you allow for recycling in your economy, okay? You have more green capital, and then it also allows you to have more energy consumption. If you have more energy consumption, you have more well-being in your economies, okay? If you just isolate the effect of recycling on your economy. A relatively counterintuitive or surprising feature is that you have an earlier fossil resource use, okay? So you use more of your resource use and you have earlier exhaustion, which in our jargon is called green paradox, okay? But that's a short-term one. At the end of the day, I mean, you emit the same quantity of fossils, so that we don't consider that as being really a huge issue. But what is important is that, and I'm going to stress that for the end of my talk, is that, well, in order to be able to recycle, you need to build the capacities that you are going to recycle, okay? And this is why I put this graph on the screen, which is we have some type of overshooting of your green capital because of recycling. So what it shows on the graph, if you were at 1, the stock of capital would be the same with and without recycling, okay? KR is with recycling. And you see that you actually are above 1, and you even overshoot your long-run level because you need to build this capacity that then you can recycle, okay? A consequence of that is that it takes time to recycle. So you cannot decide that by tomorrow we will be able to get a given percentage of minerals that come from recycling, because you need to have something to recycle, basically. And also another byproduct, so that's not in the model, but we can think about it as well, is that when you design your product, when you know that they are going to be recycled, the design of your product can be different because you can make sure that it is easier to recycle. So maybe it's going to be a little bit less efficient product, a bit simple product, but it can be interesting that it is easier to recycle at the end of the life. So to conclude, this is coming from another paper. I think we have to keep in mind that what is eventually pushing fossil fuel out of the market are taxes, okay? And I think we should be careful with, putting taxes and subsidies on the same plate as we sort of did this morning, because we also have to keep in mind that subsidies, they are very costly in terms of public finances, in terms of welfare, even if they are a lot more accepted, okay? So we can say that this is some type of cost of acceptability, and subsidies, they also lead to over-accumulation of green capital, okay? So thank you very much.